Testing, testing. Testing, testing. Right. Okay, testing, testing. Sorry about that. Okay, welcome to Programming Rainbow. In this video, we're going to start a new series. This is going to be the game Don't Eat the Yellow Snow in SDL3 and C language. This is video number 1. If you would like to follow along with this video, you can go to github.com, Programming Rainbow, and this is going to be called Yellow Snow C SDL3. Okay, I want to show you the two projects. Firstly, the final project we're building here and the project that's coming after this. So I'm going to build the final project from video number 8 because I haven't re-deleted this yet, but it should be, the final project should be in source folder as well. This is the second recording of this video. So final project from video number 8 folder, and I'm going to mute the music, and we can move the snowman around and we can collect the white snowflakes, but we do not want to get the yellow snowflakes because the yellow snowflakes are not water, they're pee. Okay, so if we get a yellow snowflake, then the game ends, and we can press space to restart it, and you see the score restarts. So that's the project we're making in this series right here, which I'm going to try to keep short, 8 videos or something like that. But the project that's coming after this is going to be this one. And this is the same project, but now I've created a neural network to play this game for us, and this project will be about what the neural network is, how to train the neural network, which is what we're going to do there, and then how to make the game play from its own neural network, which is what I'll show you right now. And I can't mute the music on this one. I'm sorry, I didn't add that option in, but we will add it in when we're coding, but just the version I'm showing you doesn't have it. Okay, so this is playing itself right now, and it's not great. It is okay. It gets up to about like 30 usually or something like that, but every once in a while it just randomly runs into the wrong one. And this is something that you could probably make better, but it's showing that this neural network is in fact playing this game. And there's going to be lots of different options on how you can set up the neural network and how many hidden layers and what size the layers and everything else. So that's going to be the project after this one. So I'm going to record this series, creating this game, and then the next series is going to be turning that game, creating a neural network and using that game to let it train itself and play itself with that neural network, okay? So I tried to record this earlier, and since this is the first video, we kind of have to set up a whole bunch of stuff, and I really wanted to show code along the way, but there's no real way to do that. So I'm going to show you all the functions we're going to do, and I'm just going to kind of dive in and push forward. Usually I like to run the code many times. Every little bit of code that I add, I like to compile it and run it. But because this is the first, kind of, we're bootstrapping the project here, it's a little bit harder. So let's start with the functions that we're going to use. I'm going to be using SDL init to bring SDL online, SDL quit to take it offline, SDL delay to pause the program. And we're going to be pulling events so we can check if we want to close the window to quit, pull event, and that is the actual events. And we'll talk about what those are. And the keyboard events as well, the scan codes for the keyboard. We're also going to be creating a window, destroying the window, creating a render, destroying the render, clearing the render so it can be drawn, and then presenting it so it is drawn. I was told before that people using Mac OS, it wouldn't, if we're not pulling the events, it wouldn't display it on the screen. So we're going to make sure in this video that we are pulling events, and that it'll display for everybody. So let's go back here again. If you are on Linux or a Mac or a system that is using ClangD, I have ClangD set up here. This is specifically for Mac people because the LSP that I'm using is using ClangD. And this is adding the include directory for Homebrew. So if you've installed this on Mac OS, you're probably installing it through Homebrew, and you're going to want to get SDL3. Let me just show you here. Down here for Arch Linux people, you can install SDL3 through the normal package manager, Pacman, but the AUR, I believe, is still where you get SDL3 image, SDL3 TTF, and SDL3 mixer. You need all 4 of those packages, the base SDL3 and the 3 add-on packages. So if you're installing this through Brew, you still need all 4 of those packages as well through Brew. If you're on Windows, I have no idea. I can't help you there, Windows. Okay, so basically, this is adding for the Mac people. If you're using Clang, this is going to add it for when you're looking at it in your editor, whatever your editor is, as long as it's using Clang D for your LSP, you won't get any errors about it can't find where SDL is. And to make sure that you know if SDL is installed correctly on your system and that you can use this make file, if we just go down here, I'm using package config, so I'm just going to grab this command right here. I'm going to yank this, and I'm just going to paste it in here just to see what it says. Okay, so this is package config -- libs, and then SDL3, SDL3 image, SDL3 TTF, and SDL3 mixer. Okay, so that command worked, the package config command worked, and it actually returned me that it did find those libraries. So if you can run this package config command and it does return that it did find those libraries, you probably are okay for this project. If you didn't get something, you probably need to make sure that SDL3 is installed on your system correctly. Okay, so now we are just going to start building. So unfortunately, we are going to have to build a lot before we see anything on the screen. So that's why I showed you this functions ahead of time. Particularly, I'm going to make a game struct that I'm going to instance. And in that game struct, since we're going to need to build, we're going to be holding a pointer to a window. This create window returns a window. And we're also going to be holding a pointer to a render. And we are also going to be holding this event. We're going to hold an event, a union event that we're going to populate. So I'm going to put all of those in a game struct. So I'm going to close all this stuff down. I'm just going to delete the source directory. Okay. And then I'm going to recreate it. Okay. So now we got an empty source directory folder. If you've just pulled this from GitHub, that is going to be the final. That is going to be the same code that's from video number 8. But you can go ahead and delete that. Again, it's the same code that's in video number 8, so you can always copy that over later or compile it from that directory. So I'm going to create 6 new files. I'm going to create game and game C and H. Those are 2 files. I'm going to have main C and H, and then I'm going to have init SDL C and H. And init SDL is just so I can put the initialization of SDL into its own file because the function is going to grow a little bit longer. Okay, so I'm just going to create those now. Main.c, main.h, game.c, .h, and then we can do init underscore SDL.c. Okay, so those are the 6 files that I'm creating. Hello. Hello, Emmanuel. Okay, so I'm going to start in main first. So the first thing that we need to do in main is we need to make sure we have access to SDL3. So I'm going to include SDL3 / SDL.h. And on a normal Linux system, the header files is going to be in user include, something like that. And it's in your normal path already, so it's all good. And it's going to be in a subfolder called SDL3. That's why we have SDL3 here. And then the file it needs is here. If you're in Mac OS, you've probably installed it through Brew, and like I said, I've added that location into this .clangd so that you have that as well. If you have it in a different location, then you'll have to add whatever that location is. I'm going to be using bools, so I'm going to include that too. So it's the standard bool. We're going to be using printf and fprintf. So we need standard IO. And we're also going to be using cowlick and exit status and stuff like that. Exit failure, exit success, and those are in stdlib. Okay, so one last thing that I want to add to this file is I'll do it when we need it. So right now this is giving us enough to move on. And what's going to happen here is I'm going to add in this main H to every other one of my H files. All of my H files are going to import this main H or include it. So I only need to put these things in one place. I don't need to keep telling it that, they're just going to be there. So when we go to game H, first thing I'm going to do is put my include guards on, which I should have done in main as well. Unfortunately, I forgot. I'll come back and do it. But the if and def, and this one's game H, and then define game H. Those are our include guards. And I'm going to include main.h. And this is not right. The LSP was trying to help me out, it looks like. Okay, so before I forget, I'm just going to go ahead and take this over to main. Okay, so main has its include guards on, and I'm make sure that they are actually named correctly. This should be main, not game. Okay, now what I'm going to do here is I'm going to make a struct. So the struct is going to be called game, and then there's going to be functions that work on that struct. So this is where we're going to be holding those pointers, the pointer to the window, the render, the event itself, and I'm going to put a bool in here is running. So I'm just going to put those in right now, and I'll show them to you again when we come across them. But because we're bootstrapping this, I'm just going to do this all now. SDL. This one's going to be a render. And then a window. And this is a pointer to a window and pointer to render. And I'm just making up these names, render and window. You can call them ren and win if you want. So for the event, the SDL event, it's not a pointer, it's just an actual event where I'm just going to call it an event, which is just a union. And then we have the bool. I'm going to say is running for the game loop to know how to break out of the game loop. And semicolon there. So this is going to be the setup for that. And in game C, I'm going to instance this game. I could actually, hold on, I can go back into game H and put the function signatures here. So the one that is creating, instancing the game using cowlick can fail. So that's going to return a bool. There's going to be one that cleans it up, which doesn't return anything. So that's going to be void. And then there's going to be one that runs the game loop, which doesn't return anything right now. It will later, but right now it doesn't. And that's going to be void as well. So it's going to be a bool on the new. So this is game new struct. And since I'm cowlicking inside of this function, but it's for something held outside of it, it's going to be a pointer to a pointer. because I need to affect the pointer that's held outside of this. So we'll call it game free to clean it up. And I'm also affecting the pointer from inside this function. So this is going to be a pointer to a pointer again. Now on the game run, I'm just using the pointer. I'm not changing the actual pointer itself. So I'm going to say game run. And this one's just going to be, instead of saying game is a pointer to a game struct, I'm going to say G is a pointer to a game struct. One second. Okay, sorry about that. So these are the functions we're going to start out with right now. So I'm just going to grab these function signatures. And all these functions are going to be used in main, basically. So that's why they're in the header file, so they can be visible. So in game C, we're going to include game H. And here's our function signatures. Okay, so let's look at new first. So the what can fail in here is we're going to be callocating the game struct. And so that's, since we're changing the pointer itself, we're allocating memory and we're returning an address, and that address needs to be stored in that pointer. That's why we have the pointer to pointer here. But it also means we need to dereference it. So I dereferenced it one time. Here's calloc. We're using calloc, not malloc, because malloc will just give you uninitialized memory. Calloc will zero, the memory will be zero initialized. I much rather have my memory zero initialized than to be garbage data. So I only use calloc. So size of struct game. And if this fails, it's going to return a null pointer, so we can check if it's a null pointer. And if it does, we are going to return false from the spool right here. It's going to return out of the spool false, and we can give ourselves some message. So I'm going to use fprintf because it's like printf, which is print formatted or something like that. But this one is we can choose the file that it's going to. And in Linux and Unix systems, that file can be standard error instead of standard out. Since this is going to be an error message, I want it sent to error. So I'll use fprintf and then standard error. So it goes to standard error. And then our message is going to be error in calloc of new game. Okay, so that is us populating the pointer there. And I don't want to keep dereferencing game now. So what I'm going to do is give myself a local pointer called G. And I'm just going to dereference game one time. And so now I can just use G. It's not really using it in this video that much, but in future videos we will. One thing I can do is set G is running to true. Did I not call it is running? Is running. Yeah. So I was just expecting it to autocomplete. It didn't. I'm not sure why. So if nothing failed here, we're returning true out of this function, and that's what a function's going to look like right now. This is the problem right here. Okay. And this one is true. This is going to be our sentinel value that breaks out of the loop. This is what we're going to loop until this is no longer true in our game loop. So that's the sentinel value. So we really need another function here, but this function is the bigger function that we're going to put in a different file. And that function is going to be game init SDL. So I'm going to go into game again, game H. I'm just going to yank this real quick because I don't want to type the include guards. I'm just going to delete this. And this will be init SDL. Okay, so init SDL, and we're going to have one function. It's going to be game init SDL. So what's happening with this is basically this function should be in game C, but I don't want game C to get so big, large, and polluted. So what I'm doing is I'm just putting it in this init SDL instead. So I'm naming this function game because I think of it as being part of the game module, part of the game. Game has a struct and functions that work on the game struct, and this is another function that works on the game struct. So, but I don't want to keep it in game C because I don't want game C to get so big. This function is going to do one thing, and it's just going to bring SDL online, all of it that needs to be done. So it's going to grow a little bit, and so I'm putting it into its own file. So I pretty much like since this is game on working on the game struct, I'm just using G for simplicity. When I have a pointer to a pointer, I type in the whole name game. But when I'm inside of the game module and I'm doing game functions, I'm just going to call it G. And yeah, there's no other. So right here, this is going to be game. And this can fail. That's what it's complaining about. I didn't have, sorry. This is going to have lots of things that can fail in it, so it's going to return a bool. Okay, so that's everything. I'm just going to grab this signature and bring it into the source file now. Oops. Mm. Give me one moment. Okay, sorry about that. So this is not game H, sorry. Something was happening and I had to go check. So include init SDL. There we go. And the function, there's our function signature. Okay, this needs to return true. So what's going to go in here? This is going to be initializing SDL. So let's go look at the functions. First thing is SDL init. And this is going to take a flag. They're down here. So right here is the input. It can take an SDL init flags. as a flag. And there is audio, video, there's events, stuff like that. Audio and video both already take in events, and we need events. But we only need video right now because we're going to display something on the screen. We don't need audio. So we can OR these together, but I'm going to hold this. Instead of putting this directly into the function, I'm going to create my own pound define that I'm going to call SDL flags. And I'm going to put this there because later on I can just add in other flags that I want, and they're all going to be in one place, and I know where they are, easy to find. So I'm going to put this in the main.h header file. So I want SDL init video, and that's going to be what's used going into this function. If this function fails, it's going to return false on failure and true on success. So it's opposite of SDL2 style. Okay. And then to clean it up, we're running SDL quit. So the first thing I want to do is go over to main, and I want to create that pound define. So I'm going to call it SDL flags, and it needed that SDL init video. That's the flag we want. Like I said, later on we can add more by putting a pipe here, and we can put more stuff. So I'm just going to leave all the flags here in one spot so I don't have to look through my code to find out where they are. So I can just wrap this in an if statement and put a bang on it, because if it fails, it's going to return false, right? So I could say if it fails, not if it's true, init. And now I can just put that flag in that I already set up with the pound define, which is SDL flag. I could have put the flag directly here, but then later on I would have to edit this and add in more stuff, whereas I can just change it now in the pound define when I need it to be different. So if this fails, I'm going to create an error message. I'm also going to get the error from SDL. So where is it? Maybe I didn't pull it up. Yeah, to get the error message from the internally, it's just SDL get error. So fprintf. And we'll call it error initializing SDL3. I'm going to put a colon on it, and then I'm going to have this %s for a string and a new line character. Okay, that's because I'm going to be getting the internal string of whatever the SDL error was. So this SDL get error is the function. So some error has happened here, right? So I can actually get what that error is and put it here. So this whole string will be this string and the error as well. And then I'm going to return false. So that means this function is going to return, and it's going to be a false. So it's going to be bad. Yeah. So that's what's going to look like now. That we can go back into game, and this free function now. Well, we've called this, so we need to take care of it. We need to remove it. So the first thing we need to do is make sure that there was actually memory. You know, this could have returned null, and there is no memory, and this pointer is a null pointer, right? If it's a null pointer, we don't want to process it. So I'm going to first check, and we have to dereference it one time. So this game. So if that is something, if it's not null, it's something, then it has an address. If it doesn't have an address, it's null, which is false. So we just need to see if it's populated. Looking at my notes. Okay. So if it is populated, I don't want to keep dereferencing game because it's going to be harder in some instances. So I'm just going to create a local variable. So that's just going to give me G as a pointer to game struct instead of having to dereference this over and over again. And right now we just need to take SDL offline. So that's how we would take it offline. And then I also need to free the memory that was allocated on this calloc. So we can free G, and we can set G to null, which doesn't really matter. G is a local variable. The freeing happens, that it's free, but setting this to null is only going to happen locally. The real one is if we dereference game and set it to null, that means the real game is set to null now that we freed up here. These two are the same, except this one, when I set this pointer to null, this is only locally happen. When I dereference game one time and set it to null, that's the one outside of this function. But I could free either one of these. I could put game like this, and that would be the exact same. It would free the same thing. Okay, I'm just going to give myself a little message here. This one's not fprintf, it's just printf because I'm going to standard out. So I'm going to say the, let's see here, all clean. Yeah. So there will be more stuff in here later. So this will make more sense why I created this local G variable. But right now, since we brought SDL online, we're taking it offline. Okay. So we have this weird thing like I could make it where I can open a window and close a window and everything else, but people on macOS won't see it because they need it to be pulling events. So, I'm not going to show too much happening right now without pulling events. So we've opened SDL and we've quit SDL. Here's a delay. We'll come back to that. Polling events. So what happens is in between each game loop, whatever stuff has happened since the last time that you went through your queue of events and emptied them out, and you've gone through the game loop again, now you're going to have another queue possibly of events waiting for you. And they could be mouse movements, key presses, key releases, things like that. And the event is a union because it can be, you don't know what type it is going to be. It could be a mouse movement, like I said, or a key press. So it's represented as a union because that's more efficient space-wise. So this event is a union, and like I said, it's a queue of events. So SDL pull event takes the top event, it takes it off that event queue and it returns it to you. It populates this event and returns it to you. It also returns from the function. Well, it's not returning this, it's populating this because we sent in the address to it, but it's returning from this function true or false. True means that this event was populated, and false would mean that there's no event there, so we don't need to worry about it. And when you can set up a game look like this by putting while, and we have this is running, so you can say while G is running, and they're creating this SDL event right here locally, but we've put the event in the game struct. And then you can do while, and you can pull event and put in the address of this event for here. It's right here. That's it. And here's the address of it. So, and then this keeps returning true until there's no more events left. And then it's going to return false and you're going to break out of this while loop. Okay, so we're going to be doing that. Yeah, I'm just going to set that up first. So I'm going to make another function here. This is also going to be void, and it's going to be called game events. And we're just going to do like it said, we just want to look through the events. So here we're looking at the internal part. We're still going to have the external one, but this is going to call our game. So imagine right here, this code right here is inside our call game function. So in here, we're going to do the while loop on the SDL pull event. SDL pull event, and we need to send in the address to where our event is, and I put it in the game struct as event. Okay, and we're going to run a switch statement on this. So this is going to go through all of the events in the event queue, and we're going to switch on the event type. So let's look at this events again. Remember I said the event is a union. So go over here. Here's the type event right here. It is a union, and it could be one of these things, any one of these, which is actually a struct. But each one of these has as its first member a type member. So we're looking at the quit event right here, SDL quit event. So SDL quit right here. So if it was this, we would look up the type. So SDL event type, right, is SDL event quit. So we need to check the type before we go any further. And it gives you a list of all the types right here, which is great. SDL event quit is right here. So that's what we're switching. We're switching on the type, and we're gonna match it with this. So I'm gonna say switch, and this is gonna be G event. So this function took in the address of the event and populated it. Now we have that event, and we need the type, dot type. And we're going to say case. Now we're looking for, is it an SDL event quit? That means something has asked this program to shut down. Like you click to close the window or use a key combination to close it, however that works. Something has asked this program to quit, and it won't quit automatically. We receive that event, and we're the ones that make the program quit. So the case is SDL event quit. Now, if it is a quit event, we don't need to look at it any further. We already know it just needs to be shut down. So what I'm going to do is I'm going to set the is running that we're going to use in a minute here. This G is running to false. And then I am going to break, because you should do that on all case statements that you don't want to follow through. I'm going to put a default in, and I'm going to put a break on that. And this is void, so I don't need to return anything. Okay, so you don't really see the event loop here. Where is it? So we have this game loop on the outside, and on the inside we have the event loop. So we have this event loop on the inside here, and then down here in run, we're going to make the game loop. While. So while G running, and we don't have to put nothing else. Why that's true. Okay, so this is the game loop. And we don't want this to just cycle forever. We wanted to call this event, right? So it's constantly looking if game events, right? If the event quit ever happened, we're changing this is running to false, and this while loop will stop working. And we don't want to run the CPU up, constantly. We only need to run at about 60 frames a second. So I'm going to put a delay of 16 milliseconds, which will roughly be 60 FPS. That's roughly because we don't know how long the game code takes to launch, and it's actually 16.6666, but you can't put, it doesn't take a float, but it's going to be close. We're going to get like 60 to 62 FPS right now. Later on, we will make this actually 60, but for right now, I'm going to use SDL delay. And this takes in a UN32 and it's for milliseconds. So that would be 1,000 milliseconds to 1 second. So I'm going to put in 16 milliseconds, and that's roughly going to cause this program to run at 60 times a second. Okay, so basically all that's happening is we're calling event and nothing else is happening. Okay, I'm going to just keep going from here because this is not enough to see anything on the screen. So we have the So like I said, we don't need to process any further. We will come back to events in a minute here, but this quit event is going to be enough for right now. We'll come back to the keyboard, come back to the scan codes. So we need to create a window. We need to create a renderer and display it. Okay, so creating a window, we need the title of the window. We need a width and a height, and then we have some window flags. And we don't have to put anything in for the window flags. We can actually just put 0. But you could put, say, like shown or something like that. Maybe shown's not here. Yeah, I'm going to put 0 because I don't need any of these flags. So I'm going to have a title here, a width and a height, and 0 for this function. And this function returns a pointer. So I'm just going to set up the constants for the width and the height and the title real quick. So this will be, let me just check what I named it. I think I named it window, but I could be wrong. Yeah, I did. Okay. So this is going to be window title. And the window title is going to be don't eat. Like that. Don't eat the yellow snow. And window width and window height will be 800 by 600. $800 and defined window height as 600. Make sure you don't put semicolons on the end of these. So we need to go into the init SDL. We already have this, but what we need to create a window and a render. So we've already have a null, a 0. It's initialized to null or 0. A window in game, which is G. So we can say G window equals, and then SDL create window. Let's go look at that. So if this fails, this returns a null pointer. So this is a pointer to a window. It returns or null on failure. Yeah. So this is going to be true or null, true or fail. If it's no, it's going to be populated, sorry, which is going to be good, or it's going to be null, which an error occurred. So the first parameter is the string for the window. So that's window title. And then we have width and width and height. It is width first, yeah. So window width, window height, and for the flags, I'm just going to put 0. And we're going to check to see if this failed. If it did, I'm going to put something similar to this. So I'm going to say if bang g window. So basically, if this is not something, if it's null, basically, I just yanked this from up here. It's going to be similar. We'll say error creating window. Error creating window, same get error and same return fault. So that's going to give me the window. And to remove it is create window, and then we have a destroy window. Destroy window just takes the pointer to the window, and it doesn't return anything. So this is initializing SDL, and game will be bringing things offline. So we have game free right here, above SDL quit. We can do, we could say if, or we want to know if the window pointer, so G, if the window, we can say SDL destroy window, and we just give it the pointer to the window. Equals null. There we go. So that's how we're going to bring the window offline. So I'm going to get rid of that create window, destroy window. Now we have a create render. And this one needs a pointer to the window, and it needs some const name. So this name is like the name of the backend renderer, and this isn't something we want to mess around with. So we just want to put, I think it's 0. Returns a valid render or null, yes. Okay, it says null to let SDL choose one. So you can either choose the driver you want, which is way beyond the scope of this video, or you can put null. So I'm going to do the null one. So we're going to do a pointer to the window and null. And this is going to be in init SDL. So this equals SDL create render, and then we have G window. The next one's going to be null. The other one is for like if you're working with Vulkan and things like that, you need to know what you're doing basically for that stuff. Okay, I had an extra E in there. So create render. And the same thing's going to occur if it fails. So I'm just going to yank this. So there's the render, and this is creating render. Now that the render is online, we need to take that offline as well. So to take the render offline, we just pass in the pointer to the render, and that does what it says. So it's in game C. Second. Okay, so it's very much like this one. I'm going to put it above it because it's last in, first out. And this is going to be render. And it's destroy render, not window. Okay, so we have brought SDL online. We've created a window. We've created a render. Now we've destroyed the render, taking it offline. We've destroyed the window, and we've taken SDL to quit. All right, and we have a simple events, and we have this guy. So let's kind of set some of this together so we can launch something. So let's go into main. So I would include main.h, but I actually also need to include game because I'm calling game functions from here. And game already includes main, so I'm just going to include game from here. So this one's just going to be void. And I'm going to set up an exit status as failing already. And if it ever gets to the positive path where nothing has gone wrong, it'll switch it to exit success. Otherwise, it's just going to say failure by default. So I'm going to do that. So bool exit status equals exit failure. Sorry, success. No. It is failure, sorry. Okay, so now we want to create this game that, we have to have a pointer that is going to be calloced, right? So I'm going to make it here. The pointer is going to be on the heap, but the game is not really on the heap. So we just have this null pointer. Now we have this game new that we need to send in the address of a pointer. Game new. And as a parameter to it, we need the address of game. And if nothing fails with that, I'm just going to change the exit status to success. Sorry, exit. It's not SDL. Exit success. And we don't just want to bring, we don't just want to create a new game object to game new. We also want to run the game. So if this did succeed, we want to call game run. Yeah. So we want to call game run. Game run can't fail, so we're not going to do any if statement on that. And then we want to change this to exit success. So if game new fails, this stays failure, right? But since we're checking to see if this did exit successfully, and this one doesn't matter, we're setting it here. Otherwise, it's going to be failure by default. Okay, so we have that running now. We need to call game free. And this is going to now return from this function whatever the exit status is. Int this isn't right here. It's supposed to be the address of this. And free is also supposed to be the address. So game run just needs to take in a pointer to a game struct, but game new needs the address of a pointer to game struct, and so does game free, because these are actually going to change this pointer themselves. This pointer is set to null, and in here it's going to populate it, and in here it's going to free it. So they do need to be there. So that's everything that's going to be in, well, yeah, that's everything that's going to be in main. So basically what we have here is we haven't created a screen. Well, I mean, sorry, we have created a screen. We're not clearing the render or anything. So I'm going to try to compile this and see where we're at, because we've done so much code. So I'm going to run make clean debug run. Make clean just says, I'm not continuing with code that I've just done. I actually switched directories that I'm compiling. And the debug means all the strict flags are turned on and the debugging information's in place, and run means to go ahead and run it. Okay. So it looks like we haven't set up our prototypes. So game event needs a prototype. I think is that the only one? Because this function's not seen outside of here. I just forgot to forward declare it. Okay, so it's not opening a window or anything. Did I leave myself a little message for the cleanup? Yeah, I did. I wonder if it's calling my cleanup function. So we're not even like are we calling the init SDL? We're not calling init SDL, so we're not even initializing SDL actually. So let's do that. We've already created the function. It's here, game init SDL, and it returns a bool. That means it can fail. So in game C, this function can also fail. So I just need to propagate that failure down. So I'm just going to use an if statement, bang on it, game init SDL, and it needs a pointer to game struct, which is G here. Now, if this returns a failure, we're going to return a failure from this. So it's going to return false. Now, I'm not sure, did I put this in the header file? And it is in the header. Oh, I know what I didn't do. I didn't include it. So remember, this is just kind of an add-on function in a separate file, so I need to include it. So this is going to be init underscore SDL.h. And it's not here. Sorry, it's in game, not main. So I'm just going to delete it and yank it from here. And Then right here. There we go. Now we have access to that function. So if this function fails, we're just returning false as well. So if it returned false, we're returning false. And that's going to initialize SDL. And we already have in place how to shut down SDL right here. Okay, that's expected. Now I'm going to close it. And it says all clean. That means it did run my cleanup function. And I'm running the debug build. If I had a memory leak, it would tell me about it. And let's check that out. Let's not freeze something. I'm not sure if it'll work here because SDL quit may freeze stuff for me. So we may not get an error. Hopefully we will. They've done some weird stuff under the hood with SDL to like try to clean up after people. So I'm just gonna run it again. Yeah. Yeah, it's not going to, let's see. Well, we can do this and not free this. Yeah, there we go. So we got a memory leak because I didn't free the game struct basically. But SDL will sometimes give you and sometimes not. So I don't know if it's being dishonest or if it is just cleaning up for you some stuff. So we are creating a render in a window, right? Let's go into SDL init. So there's our window, there's our render. So let's use those windows and render. And we saw the window pop up, but it didn't look right. That's because we actually need to tell the render to clear, and then we need to present the render. And that flips the buffer so we can see it. So if I do that, we'll see a black window. So it'll be SDL render clear. And it's render, not renderer, which is a little bit strange. And we need to pass in the pointer to the render, which is G render. And this is where we do our drawing. I don't have anything to draw just yet. And then we're gonna present the render. And this also needs a pointer to the render. All right, let's try that. Okay, now we have a black screen. I'm gonna tell it to close, and it looks like it closed fine. So I want to add one last thing to this. We're doing the pull event where we're getting if it's a quit, but I also want to quit on escape. So we're gonna go back into here. We're gonna look at these events again. And if you don't understand the stuff I'm talking about with this, maybe I've gone too fast and skipped over it. Hello, on Twitch there. If I've gone too fast with it, I do have a series that is Beginner's Guide to SDL3 in C. So I'm not trying to recover information in depth that I've already covered there. So if you didn't understand anything, check out those videos as well. Here, we're just trying to make it a game. So I am explaining things, but I'm kind of moving along a little faster. So on this event, we know that it could be a quit event, but it can also be like a keyboard key press event, right? So these are all the different ones it could be, but down here it kind of shows you this is the type that it could be, and this is what that union or that struct can be inside the union. Sorry, this would be the struct inside of the union of the event. So we're looking for a keyboard event keyboard up and down right here. If it is this type, then this is the struct that it is. And I've already opened that here next to it, which is keyboard event. And this is what's in the keyboard event. So the type would be keyboard up or down. Maybe down is what we're looking for here. And we have this SDL scan codes. So this is the physical keyboard, and I'm going to check that. So if we look over here, we have the scan codes, and here's all of them. And I'm just going to use the escape scan code, which is going to be SDL underscore scan code underscore escape right here, which is also 41, it says, but I'm just going to use that. So on this event, I'm going to add a new event. Case SDL keyboard, key up, key down. Sorry, it should be event. Event. Let me just double check it. It is. Well, it says it here too. SDL event key down. Okay, so if it is that, we need to check which key it is. So this is the C language, which is what the SDL library is written in. So this, pairs with the SDL library very well because it's the C language. Right here, I'm just going to my notes. So we're going to run another switch statement inside of this. If this is an event, if the event here was a key down event, we want to know which key it was. We can have different things happen under different keys. So we can say switch. And this time we're going to switch on the scan code. So it's going to be event dot, I think it's called keyboard. Key. So the event is going to be key, which is this type of struct, but the member name is key. And then scan code. That should be right. Let's just double check. Oops. Yes, it's called scan code right here. And then here are the scan codes, but we already know it's SDL scan code escape. So this will be case SDL scan code. SDL scan code, yeah. Should be like that. And if it is that, we're going to do the same thing. G is running equals false, and then break. And then we're going to put a default. Break. Let me see where the error is. Yeah, this is G event. Okay, so we have a default here, a default here. I think this is correct. So that'll allow us to close it on a key press. I don't need to do a clean. I'm just going to run it. Press escape now, and there we go. It cleans. Yeah. Okay, so basically, I'm going to delete these up here because these don't need to be here. They're already brought in. Okay, so this is kind of all the boilerplate, and this should be showing up on Apple II since I'm pulling events. And what we have here is main H holds any common global constants which is the window title, the window width and height that we will use in other places. The flags, just because it's convenient for me, and the things that we've included, the header files we've included, so I can use them in all the other files. And then game has this struct that's holding a pointer to a render, pointer to a window, an event, and a bool is running. It also has these functions that can be called from main, the game new, game free, game run. So in main, we are creating this exit status bool. We're setting it to exit failure. We are creating a pointer right here on the stack. Although the memory is being allocated on the heap, the pointer is, right here. Once we have this pointer, we're sending the address of that pointer into game new, which actually callocs the memory. If that fails, it's going to skip this, and exit status is still failure. It's going to attempt to clean up whatever it can clean up, and it's going to exit with that failure status. If it succeeds, it's going to run game run, which can't fail. There's no failure on that. So, and then it's going to set exit to success. It's going to exit out of this if statement. It's going to run this free anyway. So whatever is there, it's going to free it all. And then it's going to exit with success. So that's where it's going here. It's running the new, trying to run it, and then it cleans up after itself. So in game, this is where we are callocking that game right there, where the memory for it. So we need the pointer to the pointer of a game struct. We dereference it to calloc it. We check to make sure that dereference pointer is not null. And then I'm creating a local G so I don't have to keep dereferencing that. I'm setting G to true, G is running to true, so we can have our game loop running. And we need to bring SDL online now. So I'm calling this other function game init SDL, which is here. And this is bringing SDL online with the flags that I've set in main H. Then we are populating the window with the window title, window width, window height, and 0 for flags. Though if you want a flag, you can put that there. And this will return a null pointer if it fails. So we're checking to see if that failed or not with the pointer. Same thing with render. I need the pointer to the window. We're going to let SDL choose the rendering backend for us. So we're not doing that manually. So this is going to be a null here. And if this fails, it's going to return a null pointer. So we're checking that. And we're using this SDL get error to get whatever internal error happened. So since we brought all these things online, we're also going to take them offline, which is in game, how we clean up right here. First, we make sure that game pointer is valid. And then we're giving ourselves a G that we will be using later. I'm not using it right now, I understand. Well, we are using it these two places. But if the render, so we're making sure this pointer is valid. And then if this pointer, the render pointer, is also valid, we're going to destroy that, set it to null. If the window pointer is valid, we're going to destroy that, set it to null. We're going to shut down SDL. So we're doing it in reverse order. And then we're going to free G. This could also be game as well. It could be game like this, dereferenced one time. But anyway, free G, set G to null. This is just G setting it to null is local, although it did free the actual heap allocated memory no matter what. The actual pointer is local, so this is the pointer that exists outside here that we're, the dereference one. We're giving ourselves some message. So that's how we're taking everything offline. And then inside, main was running this game run. So that's what this is right here. It's just a while loop. Keeps running while is running is true. We check events. Our events are just checking to see if any of the pulled events are a quit event or a key press that is the escape key. If either one of those are true, we're setting is running to false. And so, like I said, if either of those are true, is running gets set to false, and we come out of here. Or at least it goes through one last time, and then it bails out when it gets back up here. To actually see something on the screen, we need to clear the buffer that you don't see, the render. You don't see it yet still, even if we clear it. We have to present it. And any drawing that we do happens between these. We clear the buffer, we do all our drawing, then we present the buffer. Okay? And to run at about 60 FPS right now, we are just putting 16 milliseconds in there. This will be made more complicated later, but this is just enough to get us up and running. Okay, that's a whole lot of boilerplate for this video. Let me just see what people are asking. Have a good day then. He just said bye, have a good day. And let me check YouTube. Hey, how's it going? Hey, Matthew. And yeah, if you have any questions, just ask him. Again, this is so that we can create this Yellow Snow game. Let me show it one last time. Sorry, not this one. The game that we're making right here, I'm going to compile the final source. And this is the game, muting the sound. And we have a score up here. And this score is using the new style SDL3 score. I haven't shown this off yet in any videos, but this is the new style score. It's the using the text engine style. But we're creating this game that you can, simple game. But this is so that the next series can be building this where the game runs itself. And this is a neural network playing this game on its own, and it just failed. But this is more interesting, so I want to get to this point. Maybe one of these times it won't fail. I don't know. And to show you this, I can tell this to train itself, what you just saw. So it would be yellow snow, and instead of AI on, I can tell it AI train. And I can give it a whole bunch of stuff. So right now I have 16 threads in this 8-core CPU that I'm using, and I could tell it that I want it to play 128 games at one time. So it's not going to play 128 at one time. It's going to play 16 at a time, but it's going to go through the whole 128 and play 16 of them at a time in parallel. Okay, and it's going to take the top 64. So it's going to take the top 50% of those 128. Whatever ones had the best score, it's going to keep those. This is how much. This is the I forgot the Gaussian. I forgot the word. It's a percentage. Oh, I can't remember. It's the name that not deviant. Basically, I want a random distribution, and this is the number here is whatever this word is. It's like it's not deviant. It's divergent. Anyway, this is about how much I want it to be able to randomly change. So this is a percentage of the rate. So I have lots of weights and different things. So I could put this to like 1% chance it's going to change the weight. And this is a 1% on this Gaussian, whatever this word, the DEV, forgot what it stands for. Whatever this word, we'll see it in a second probably. And the fitness that I'm choosing is how long the game runs. And I'm actually telling these games to run 10 times a piece. So it's going to run 128 games. It's going to run each game 10 times. So one of these threads is going to run one of these games 10 times, and then it's going to go do the next one 10 times. And it's going to do 16 of them in parallel. So 10 trials. I'm telling the yellow to have a -10. So every time it hits a yellow one, it's going to dock it by 10 points. And then I'm telling it to run 100 generations. So yeah, so if you think about the math, how many games are happening here? So I have 128 games being played 10 times each. So that's 1,280 games. But I want 100 generations. Each time this does this 1,280 games, it's going to pick the top 64, right? It's going to average those 10 playing. It's going to pick the top 64 of those, and then it's going to do that 100 times. So this is 1,280 games times 100, right? So it'll be 100. It's going to run 100,000 games, and it's going to take like a couple seconds. So I'll just show you real quick. I just set the Gaussian to 1 and the mutation rate to 1. And I'm going to call this new 15 file name. Yeah. So what's going to happen here is it's going to take a game that has not been trained. And I'll just show this to you that it's not been trained. When I run this new, so all these switches we're going to be programming in the next thing, but I just want to show you here this when I use this file name when I use this switch new right here, it's saying I'm creating a new one. So instead of running 100 generations, I'm going to run one generation. And you're going to see the thing's going to be dumb and it's not going to do anything. Okay? And it's telling me the fitness of this. So remember, I'm scoring it as every time it hits a yellow, I don't end the game. I'm running it for like 1,800 cycles, I think. So roughly half a minute, I think, in real world time, but in the game it happens really quick. So anyway, it ran one generation and I called it new. I called the file name new 15. So if I now run this with that new 15 that I just created, it's going to be dumb. It's not going to do anything. AI on and not test 15, new 15, right? So this thing basically had one generation. Okay? I'm a bit concerned. It's doing really well. Wait, what? Wait. Did I just... Hold on. I'm going to delete the new just to make sure. Okay. Oh, not 10 trials either. I just want nothing to happen. I want it to be just basically like one trial. I just want it to have nothing. Yeah, because I was doing 10 trials. Yeah, we'll call it new 15. So it should create a new file called new 15. And it's going to have a single hidden layer that is 15 neurons inside. Okay? And now let's see how that runs. It's still doing way too much, I think. It's because I'm still creating 128 games and picking the top, I guess. But I'm a bit I'm a bit confused on why this is doing so well. I'm not controlling this, by the way. It's doing its own thing. But it is only going to the left. Anyway, that was pretty weird. Okay, so if I were to let it run 10 trials and 100 generations. This is where we have that 128,000 games or whatever, right? Yeah, here we go. So each time this number clicks up, this is a generation. So when this hits 100, we've done 128,000 games that it's played. And you'll see my CPU. Well, we would have seen my CPU jump up, but it was too quick there. It ended already. So now let's try that same one, new 15. That was new 15, yeah. Yeah, file name new 15. Now it looks like it's making decisions. It's going back and forth, although it still ran into the yellow. So this is the little neural network running. I'll show you I'll just run it again, but I'm not going to put this new switch on it. What it's going to do is it's going to continue training the what it's already trained. So it's still going to use the same file. Before it was recreating a new file. Now it's since I'm not telling it new, it's going to use the existing file. So we saw that this had 46 generations. When you see 46 here, it ran 100 generations, but it keeps the top 50%. So those don't click over a new generation. What happens is it deletes the bottom half. In the first half, it keeps the original and it mutates it one time and calls it a new generation. So the bottom half is a second generation of whatever the top half is. And that keeps happening, to whatever ends up in the top and stuff like that. So it only went through 46 generations. The top one up here at the very top had 47 generations on it. So I'm going to run it again. And so those number won't start at 0 again. It'll continue. See, it's getting bigger. And here is the CPU. My CPU, all the cores here are kind of getting maxed out. And this is when we were training it the last time. So it's almost done, it looks like. There it goes. It's done. CPU is going back to normal. So this is all happening on the CPU as well. And now I can let it play itself. Hopefully it's smarter this time. And let's just see right here. It was clicking over to a +2 and all this were negative. So basically I was running it for, I think it's set to 1800. So it's kind of 1800 ticks, which is equivalent to, if I was running at 60 frames a second, 1800 would be like 30 seconds worth. Let's see here. I'm just going to launch this and kill it right away just so I can see. You know what I did? I changed the code so I didn't see the message that it leaves. There is a, sorry, this is a tangent. There is a thing that pauses the code. I think it's an AI. I probably commented it out. It's not in neural network. Maybe it's in game. I had it pause for like 3 seconds, but then I removed it because I was trying to see if floats were faster than doubles, and they weren't. Okay, so this one delays it, and so I can see a message on the screen. Oh, did I do this new? Hope I didn't do this new one. Oh, no, that's right. So the new's confusing me because new is also a switch that I can tell it to make a new file with. I need to recompile it, so and I don't run this one. I'm just going to recompile it. Thanks, man. Okay, let's see if I can show you what I was trying to. There we go. So there's this printout of what's happening. Before it starts running, it shows this for 3 seconds. It says, hey, your file name is new15. AI is on. AI training is on. Graphics are turned off. So this thing can have the graphics turned on or off. But when we're running multi-threading, we can't have the graphics on. The fitness style is timed, and the ticks is 1800. So basically, if I wanted it to act like it was running for 1 minute, I would run it for, was it 36? Hold on, is that right? 60 frames a second, 10 seconds is 600. And then 6 times that is 36. Yeah. So 3,600 would be like 1 minute's worth. So what I'm doing is basically I'm saying each tick I can move 5 pixels, and that's going to simulate real world if I was running at 60 frames a second. I just let it run as fast as the CPU will let it run, but I make sure the physics is everything moves at 5 pixels every frame, but I let the frames happen as fast as they want. So it still acts like it would be if it was running normal. So I can change this number as well. And mutation rate. Oh, I wish it had the name. It's like deviation. It's the deviation of the Gaussian deviation. And the initial deviation I have set to 5. I don't know why. The threads, that's just because my system is, 16 threads. So we can tell this number to be bigger, but then it'll run slower. But we can also just watch let me run it again, and we'll watch how the score changes. So right up here, these are starting to be more positive numbers here. There's like 3, 4, it gets into the 4s sometimes now. So this is learning, it's training itself, it's getting better. And we're here in the -3 to -5. Let's just run it for 1,000 generations. We're not going to get better. Like, it's not going to get better. Probably 500 is good. There's a point of diminishing returns. So it should run smarter now. And I made this where we can put all kinds of different switches in, and we can tell it to we can use fitness as in time. We can use how many ticks until the game ended. We can set it up 3 different ways, basically. But you see all these numbers are positive now. This is showing me the top, I think 16. 1, 2, 3, 4, 5, 7. Is this the top 20, I think? So I think it always shows me the top 20 unless I choose, if I choose a smaller number, then I chose 64 as the top that I'm keeping. If I chose like 10, then this list would only be a size 10. But since it's 64, that's too much to display, so I just choose the top 20. But you see how the scores are better now than they were before. And we're at 400, and we're starting to get into double digits now. And these are averaged over 10 games. So when this finishes, I'm not going to keep training it. I just wanted to kind of show people what's happening with the project. But now I can tell it to run, and hopefully this one's a little bit smarter than it was. And it never gets perfect. It always gets it gets pretty good, but it never gets perfect. But that's the thing, like maybe somebody can write it better than I wrote it. It's not completely optimized, but it's definitely doing something. It is going for the white flakes and going away from the yellow flakes. And this was trained at what, 600? Something like that, 600 or 700. See, that one, it didn't even move. It just let it run straight into it. And it's going to do it again. And you'll notice it can go off the screen. This is wrapped. So the player can go off the screen. It doesn't see the screen. It just views flakes forever in front of you. The flakes behind it views in front of it. So it's like infinite, basically. I did that because of the training. I didn't want it to go to the side because it had less chance of a flake hitting it on the side. But you get the idea. That's kind of an update of what that we'll be building this in the second half of this project, or the next series after this series, where we're just building the snowman game. So that's where we're going with it. It has tons of options. Like you saw all these switches you can add to it. We can change all these and do all kinds of different stuff, and we can change even the fitness that we're choosing, and how many threads, how many variants, what chance of mutation we want, how much to mutate it. We can also tell it how many hidden layers, up to 10. Like I'm doing one hidden layer, but we could tell it to run like 3 hidden layers or 4 or 5. The training will go slower because it's calculating more stuff, but the option is there. It's like built right in. I can do it right now. Let's say new. I'll make them bigger. It's going to run slower, so I'll just do like 100 and I'll show you. I'll say 30. This is just a file name I'm giving it, but now this new 30, 30. So when I say new and this 2 numbers after it, it's going to say, oh, you want 2 hidden layers that are of size 30. Or for fun, let's make it 3. Let's say 30, 15, and like 8. Yeah? That's again just a file name. This is the one that actually makes it. This 30 here, space 15, and then 8. So we should see now that it's going to tell us it's going to create this. And yeah, we could do 5. How about 200? I don't know how much slower this one's going to be. And we'll just do 5 trials, not 10, because that'll help speed it up a little bit. So it says now and look, we're in the negatives. That's kind of where we start out. Negative double digits, and then we're going to see these negatives start to go away. And I did set the Gaussian very low, so I maybe should have set it at 2 or 5 or something. The deviation and the probability, so those are probably set too low, actually. Is that? Let me do this again. Well, yeah, I'm just going to do it from the beginning again, because let's change these up, this mutation and the... I'm going to put it to say... I never know how these should be. Yeah. Gaussian mutation. Trials 5. It's going to start from the beginning again. And see, these numbers have already drastically changed. So when you're training in the beginning, you can put more drastic numbers in for the rate of mutation and how much it mutates. And then later on, you put in smaller, more conservative numbers to fine tune it. That's weird. I ran 200 generations, but these generations, it picked the top ones. This top generation only mutated 35 times. I'm going to run it again, but shrink down the numbers here to like 3. Oh, sorry. I don't want to create a new file. I want to continue doing the same file. So I'm continuing the training of these because I'm just seeing how far I can push it. Looks like 20 to 30 up here, somewhere in the range of 20 to 30, and this is like 16, 19 down here. Okay, and now I'm going to do it again, but I'm going to drop down the mutation again to 2 and to 2. I'm going to do it one more time at 1. So this generation over here is the generation on that specific network. So that specific network, even though I've run like, what is it, 400 or 500 generations now, that network has only mutated that many times. So I'm still up kind of high 20s, low 30s here, but this has popped up more. Let's just do it one more time at 1 and call it good. And we could do this at 10 trials. Or we could set the max, was it max ticks? Max ticks, hopefully that's right, to like 36. And this is going to be, the games are going to take twice as long to run now. And I'm going to set the trials to 10. So this is going to be slower. Okay. So the reason why the score is so much bigger, because I'm letting the game run twice as long. So seeing a bigger score initially doesn't mean anything because the game's running for twice the amount of time. But will the score continue to go up? So it looks like it's in the 40, 30, high 30 to low 40 number here. And down here is like 33, 35 area. And this is going a bit slow. Hello, how's it going? But I did told it to run 10 trials of it and also to run for 3,600 ticks, which is like simulating, like I said, a minute's worth of gameplay. And it's doing it for 200 generations. That's 128 games. Each game run 10 times for 200 generations. And I'm using 3 hidden layers now at 30, 15, and 8. So you can see it kind of slows down. My laptop doesn't have enough horsepower, but you can tell I'm doing a lot of work with it. And I'm also streaming from this laptop right now too. So but my poor CPU is. Oh, it finished. Okay, so let's see if this did anything nice. So we called it new 30 right there. That's the file name. Watch it just run straight into the first yellow flake. Is it smarter? Who knows? I haven't really noticed it being smarter with more layers, but I also haven't. I spent probably more time coding than training. So it could be. I mean, it looks like it's doing well good here. It's already at 25. So that beginner's guide just tells you, it's like, I mean, SDL is for games, but it's not specific to games. But yeah, I mean, it's going to be like the guide just tells you how to open a window, how to close a window, um, how to get keyboard inputs, how to get them as events, keyboard inputs as events, or keyboard as at the keyboard state. It also, I don't think I covered the mouse in that one. I don't cover the mouse, but it's going to be similar anyway. How to load images, how to draw images, how to move images around, how to create text. So it's the beginner's guide is not showing you how to make a game. It makes a little demo, yeah, but it's just showing you the different elements so you can say, oh, if I just learned C, this is how I can apply this C language to a game now. And what I'm showing off right here is a neural network running this game. So that's what I'm showing off here. So anyway, you get the idea that I've been kind of showing this thing off too much now, but you get the idea. It's like there's a whole bunch going on here, and this is all written in. I'll show you the libraries I'm using with this, and this one I'm showing off here is SDL2. We will be doing the SDL3 version, but it's going to be the neural network doesn't matter for 2 or 3. It's the same. So this is all the headers that we're using. So again, this is for 2, so it doesn't matter. The SDL3 will be the same. But this is the SDL part. I am using P threads because this is multi-threaded program that we're looking at. Here's bool for the bools. For input output for printf. This is for calloc. This is for time for the random flakes. We just use time to seed the random number generator. And math right here, I just used it for one thing specifically because of that Gaussian. Forgot what it's called. It's a Gaussian. Basically, I was trying to do a cooler version of a random number generator with where is it? I wasn't getting the performance that I wanted, so I kind of went down a rabbit hole. Here it is, random Gauss. So instead of just using a random number generator, I was trying to be wise, and I ended up using square root and log and cosine, and this is probably completely unnecessary for this project at all. I might make this optional. But I had a thing where I wasn't getting what I wanted. It had nothing to do with this in the end, but I was, instead of just using a normal random like up here, I went down this thing. I didn't want to use any libraries, but I ended up using the math library. But this is the only place where I'm using this um, square root, log, cosine. I don't use any. The rest of the project doesn't use anything other than adding and multiplying. So the where are we looking at here? The neural network. This is how the neural network updates. Okay. It's just taking an input, multiplying it by a weight, and accumulating that for all the different inputs. Each input has its own input weight. It multiplies those together and it accumulates it. And then that is the number on the neuron. And then the number on the neuron has a bias, which is just an added number again, and then an activation function, which is just a ternary operator. Here's the bias being added right here. And this is just from an array and a struct. I'll explain a lot of this later. This is the activation function, which they call a rectified linear unit. You know, they give all these weird names for it. This is just a ternary operator. That's all it is. It's going to be a positive number or 0 is what it is. And it does that for each neuron. And that's the whole neural network. So this is a feed forward evolutionary neural network. And basically it's just some arrays, a struct full of arrays, and it just does some basic math. But I wasn't getting what I wanted early on, and it had something to do with inputs. It had nothing to do with my neural network whatsoever. And so I got fancy and I was like, well, what's the better way to do the random numbers? And it gave me this Gaussian, you know, and I was asking the AI about it and stuff. So I left it in, but I don't think this affects the performance at all of the training or, you know, so I'm going to put this as an optional later. But yeah. And my multi-threaded code is really basic. Let's see, where is it? Is this where the p threads is? No, it's in AI. Yeah, this is like my whole multi-threaded code right here. This is it right here. Yeah. So from here to here is my multi-threading. This is single threading. So when it's running multi-threading, it's just using this p thread. It just breaks up. I break up my however many games I need to run. I break them up into however many threads I have, and then I make that many threads, and then I have to join them back together again because I need to get the top whatever of the game. So this is all kind of new stuff to me. I've never done this stuff before, but it wasn't too bad actually. This is kind of simple. And all those switches, I have like an insane amount of switches that I'm putting into this. I'm taking the arguments and I'm just doing all these different things to, if I did this switch and I'm checking, did I put a real number into that? And so it's a little bit safe. You know, it's kind of checking my inputs a little bit, but I'm sure it's not perfect. But all of this in the main C is literally just inputs. It's just dealing with the, you know, the argv, argc, whatever switches I want on this, and I'm putting them into an AI struct, a config struct that I call AI config, and that's just holding. Where is it? Here, right here. This is just holding all the different switches, whatever I set it to, and they have defaults and stuff on them as well. So yeah. That's what that project's for. That beginner's guide is just to, like, when I learned C, and I just didn't know what to do with it. I was like, now how do I do something? I watched a whole bunch of very long videos on what all these things in C were and variables and everything else, and then I had no idea how to apply it. And I wanted to find how I wanted to make SDL, like a toy game. And everybody was like, "Oh, you use the lazy foo C++." And I'm like, "I don't know C++. And I don't know C enough to understand the difference between C and C++. I don't know any of that stuff." And there was just no information available. So that beginner's guide is literally if you just learned a little bit of C and you have no idea how to implement it whatsoever, that guide is just like, hey, this is what the function is, this is what the parameters are to it, this is the page, I show you the page where you find it, and I kind of talk about it a little bit more so you can understand it, and then later you can, when you do your own project, you know exactly how to find the function, how to do the function, everything else. So that's the point of that. Yeah. If I could create a copy of Minecraft, I'd probably be a billionaire right now. You know, I've seen people do it in demos in it, and like there's somebody on YouTube that creates a demo in C. It's not the whole game; it's just a demo thing. It does look very impressive. I'm sure he's doing well off too. I'm not rich. I'm poor. So, yeah, if I could make Minecraft, I'm sure Microsoft would be paying me a whole bunch of money for it, billions. Sorry about that. But yeah, I don't have that skills. I'm not that skilled. That would be nice if I could, but also I'd probably be a billionaire too. I could just make a copy of like Fortnite. I'd be set. Everything would be fine. I don't think Lazy Foo is good at all. Like I did not like I never used it in the end. I didn't like anything about it. Also, it wasn't for C, it was for C++. It wasn't what I was looking for. And even for C++, I don't think it's good. I just think it's not like maybe he made it better recently. Oh, that was very, very low quality and didn't make any sense to me, and I didn't want to follow it. So I kind of made a video series of what would have helped me, what I could have learned with that. So if it works for you, let me know. Yeah, that's the same thing for me. I was learning C, not C++. I didn't want to know about C++. I just wanted to know C first. And SDL is written in C. It's made for C. And Lazy Foo is C++, but also it's not good C++. Like as I know more C++ now, it's not good and it doesn't explain it good. It doesn't explain SDL very good. I like it seems to be the best resource, but also it's terrible. Like I think it's very low quality. So I do have C++ beginner guide um, for SDL2, and there's the and SDL3. Let me look. Like sometimes I forget. I make the project and I don't actually record the video. Because I'm not crazy about SDL3, but or C++. I mean, so let's see here. Beginner's Guide to SDL3 and C, and there may be. Thought I had one. Let's see. SDL3. Oh, yeah. Oh, Conway's Game of Life in C++ and SDL3. Oh, here it is. Yeah, I have a beginner's guide. I haven't recorded this one, but the code is here. And I have an SDL2 in C++, but this one's SDL3. So, and you can see like this is pure SDL C++ style, you know. it's all class based, and I'm using smart pointers and all that stuff. So this is for people who want, you know, C++, like kind of C++18, C++20, or whatever it is. I'm not an expert in C++, but it's much more verbose C++, and I'm not a big fan, but if I was using bigger projects, it would probably make more sense. But I kind of wanted to know C because I want to understand the basics, the basic thing first, because I figure if you know C and you want to use C++, you're even better off because you understand the basics first before you add all the extra things on top of it. But yeah, so if you do want C++, it's here. But also, like there's a whole bunch of projects here. It is true. Like I think C, if you don't plan to ever make a project in C, if you have no interest in C, I think you should still learn C as the first low level language because C is awesome. Like C shows you the right way to do things and how you can mess up. So the mistakes are even good as learning because then if you go and do something in Go or you do something in Python, you know why it happened. You know why the thing that doesn't work. Like I was in Python and you you mutate something in a function and sometimes it mutates and sometimes it doesn't and you're like why if it's a variable it won't mutate unless you say it's global, but if it's like a list or something else it will mutate and it's because it's a pointer. There's no pointers in Python, right? But Python's not a real language. Python is running on C is what runs Python, and so there is a pointer. And the fact is when you just pass in an atomic value, like a variable, it can't mutate inside of a function. But if you pass in a pointer to something, it can mutate. But in Python, you don't understand it's a pointer, so you're like confused. But when you learn C, you're like, I have to know what a pointer is now, and I have to know how to use it correctly. So now if you go back, you're like, yeah, I understand. The list is just a linked list under the hood. In C, it's just pointers. So that's why you can mutate it and stuff like that. And like I said, if you're trying to go for safety and you start to think now the what C++ can bring to the table, or if you're going into Rust, or if you're doing other things. So and they all interopt with C anyway, so it is very good. And I don't know if people like slept on this or not, but I I went a little crazy. Like I'm not a very good programmer, but I went a little bit crazy. And I watched some dude's video and he said you could do this in fourth and you couldn't do it in fourth. And then I was like, but can I do it in fourth? And I ended up making, games in fourth, or I did a thing in where is it? Hold on, let me find. Yeah, beginner's guide to SDL2 in fourth. Nobody got that because it wasn't possible. I wrote the bindings for it. So if you want to run the fourth language, you want to run SDL2, here you go. And here's the bindings. These are the bindings for fourth, and I haven't used fourth in a while. Fourth is super fun, super weird language, super fun, to use. But you know, what about old languages? What's older than fourth? Surely you can't, make an SDL2 game in like COBOL, right? But I have beginner's guide to SDL2 in COBOL, right? And it works. You can. Totally can. It was like I'd never even used COBOL before. I didn't even know you could do it. But guess what? COBOL can call C functions. So SDL is the C library, so I can just make a COBOL program and call the C functions directly. It's insane. So here is the this is like an the paragraphs, the sentences, the periods at the end of the sentences. It's COBOL. And the way you do things is you call, let's see, you tell it you're calling it, this is how I'm calling a C function. I'm calling the SDL init function, and I'm passing in by value SDL init everything, which is the SDL2 thing for bringing everything online. And then I'm capturing the return value in this return value variable. It's not called a variable. It's called a. Is it? I forget what it's called. It's been a while. It's COBOL. If I could get multi-threading Word, I was gonna do the AI in COBOL because I really wanted to, but you can't do multi-threading really. You would have to basically be calling C, and that wouldn't really be the program at that point. But yeah, this is COBOL running SDL2. Let's see if I have it. I haven't. I don't even know if I have COBOL on this system right now. Let's see if it runs. It may not do anything. Yeah, it's COBOL. Right? And yeah, see. So like, yeah, if you know C, you can do anything basically, and you understand the other languages. And yes, C has problems, but when you know how to use C, you know what those problems are. So you know when the other language is fixing those problems, or when one of them, because C, like dealing with strings in C is a pain in the butt. So you can appreciate what's happening, and you know how the other languages are doing it because they're just hiding it from you, but they're doing it the way you had to do it manually in C. So I think C is like an excellent language to learn. Even if you don't plan on using it, whatever language you do use is probably made in C. You know, like C++ is a superset of C. So like if you go to JavaScript, that's C. If you go to Python, it's C, right? How many different languages under Lua is like C under the hood, right? If you go to the browsers and you're like V8 and all those and Node and all that, that's C, man. That's C and C++, right? And then the other ones are just rewrites of C, like Go and stuff like that. So, but Go's got a garbage collector. But yeah. And I started making my own. Hold on. Do I even have? Hold on. I was being silly the other day. What did I call it? Hue? So I was like, what if I wanted to know how to make the language like how, yeah. So what if I had this and I wanted to like tokenize it? So I was making a lexer. See here, I can't remember. Yeah. So basically it's taking this code here. This is like the beginnings if you're making a language. I don't really want to make a language, but I just want to know how the language, like I wanted to know how to bootstrap a language, like running assembly. You know what I mean? Like we're a self-compiling language. So not like I said, I'm not trying to make a language because like it takes groups of people and a lot of energy, but just to understand it, that like helps a lot. So this main would be the I want to tokenize this whole thing. Even some of the stuff is nonsense and some's not. So this is how it's tokenized here. Main, and then each colon is a punctuation. Main is an identifier. Keyword proc for like procedure. For like a function name would be proc when you're defining it. Where is it? Right here. This is it. This is nonsense syntax. I mean, I was just kicking around. I just wanted to know how to tokenize it. So I wrote a lexer in C. And it's just garbage code. Here's a string literal, hello world, I'll probably, when I get bored, I'll play with this, Here's the lexer. And it's just I was just kind of messing around. I was like, how would you do this if you wanted to? And then I have the space game. So I have too many things that I want to do. So that's why I actually forget that I've made a bunch of projects here that I forgot that I made. Like this one, there's videos to this. I recorded this. But some of the others, all the SDL3 C++ stuff, I haven't recorded any of them, but I have 2 projects finished because I ended up making multiple things at the same time. When I was learning the SDL3, I made like Minesweeper. Which one? Not Minesweeper. I did the Conway's Game of Life. I did like a C SDL2 version, but then I did like all the like 4 versions or something. Let's see, there's C SDL2, C++ SDL3, C SDL3, Odin SDL2, and C++ SDL2. So I have all these versions of Conway's Game of Life, and they're like, I think they're done too, but I haven't recorded them. I only have recorded like 1 or 2 versions. So some of them are similar. When like if I know the C++ and I'm just trying to figure out the SDL3 part, when I do it, I just write both versions of it. I think for the Odin, I kind of wanted to make some Odin videos. I can't remember if I did. Let's see. YouTube Odin. So I have a Conway's in Love 2D, and then yeah, I have just the C SDL2 one for Conway, right? But I have like in the repo, I have how many versions? And they're like full on broken up into videos and everything. There's 3, 4, 5, 6. It's like 6 versions here, but I have recorded like 2 versions, so it's a bit silly. So even though I have like 15 or 20 playlists here, I have like 40 repos, and those repos are generally complete repos. Like when you look into these repos, they're it's the whole thing. Like I usually just push it when it's done and then update it as it needs to be updated. So I don't think Tetris is here. Yeah, I have Tetris coming, but I was doing something else. I was rewriting it, and then so yeah, Minesweeper. I was gonna record SDL2 version, then I thought nobody wants to see SDL2 anymore, so I rewrote it as SDL3 and recorded that instead. So I have a C++ SDL2 version and a C SDL2 version, and then a C SDL3 version. And I think I rewrote it from scratch on one of these too. So, but I have that space game that I was working on. I haven't get into it any because like editing the videos take forever. Um, this space game that I was working with, where you can design your own spaceship. Like this was the game I was trying to make, but I need my other laptop to do some Blender work, and also like you have to decide what you're working on. So, and I don't necessarily know how to do all this kind of stuff. This kind of thing took me like a week. So I worked on this for a week straight, and then I kind of set it to the side for the last week because yeah, I kind of burned myself out on a little bit. So that's why I'm playing with the neural network. Anyway, that's a whole lot of stuff. If anybody has any questions. Yeah, so this so let me show you the space game real quick. This is very early stages. I don't know how to do interfaces and like this whole thing to get the you know to get this to work. Where's one that's incomplete? So I scrolling up and down with the mouse, actually two finger dragging here. And these are the different module categories. And then this is the module. You're supposed to be able to click it and drag it into place, but I haven't set that up yet. But if you have multiple, like say, this is the module for the cabin for to hold people. If you have multiple, there would be, this is a link to list. But you're supposed to drag them into here. So it's like if I click something here, I go into edit mode. These modules click to each other. So this is just a representation of like the pilot, the bridge or whatever. And this is a different version of the bridge, and this is the crew cabin. This is like chemical storage or fuel or gas or something. This is a different one, like this is a cargo storage. This is supposed to be the shields, and you click on it, all of this stuff under the hood. This is a freaking 2D heap allocated 2D array that I have to keep allocating every time it grows. And I have to tell that, this is all manually written in C, and there's engines down here. I can scroll this around, and then I can zoom in and zoom out. If I hold shift, So you're supposed to be able to like build your ship and then you can fly it around, but you're walking around inside your ship too. So you're a little sprite character in that 2.5D, and each one of these will have an internal representation. You walk around, do your step, and then you fly your ship around, and you can mine asteroids or try to steal stuff from people or something, or deliver things. Like a fun little 2.5D asteroid games. Land on a planet, maybe walk around the planet, maybe have space stations where you can buy, it's a fun little thing. I want to build it. Like I've said, I've built this far. Basically, this is the ship editor. This is how you build your ship. And then this will then create an image from this, and that's the ship you'll be flying and everything else. And yeah, this is a game that I want to build and release. So this isn't for making YouTube videos. This is for actually making a game that I hope to be a product. But I will show it off, and I have a devlog on it already. So yeah, that's as far as I got with it, though. It's zooming in and out. This is all like, how do you do all this stuff? And I do see bugs in SDL3, like right there. It's not rendering correctly. But how do I do this menu where it closes, where I can select, where I, like, and if I rotate this up a little bit and then I come off of it, will it still stay? But over here it switches, that like this is harder than it looks. It's like once you know how to do it and you've done it a couple times, it's easy. But like the first time you do it, everything is hard. But yeah. No, C's super fast. Like if you saw me training that neural network, I'm running, 100,000 games and like simulated games that are running 1,800 cycles of each game, running the neural network and 100,000 games, and it was taking me like 30 seconds to run 100,000 games. So when this is C, this is super low level. When it like there's no, the reason why this is a bit jerky moving up and down and side to side is because this is the wheel mouse, which is done in integers. It's not smooth, so it has nothing to do with the rendering of the game or anything. It has something to do with the fact that the two finger scrolling is done in fixed integers. If I click on it with the mouse and drag it around, see, now my mouse is acting silly. Now this is done as a float and it's smooth. Well, at least it's smooth to me. I could be stream this at 30 frames a second, so you might not see it as smooth, but it's smooth to me. But yeah, no, see, super fast for this kind of like nothing's happening here. I mean, the code looks big for me, but the like the CPU sees nothing. It's sleeping on this, you know. Like, where's my look my CPUs? And this is me streaming. You know, I'm streaming right now, and what is my you know, I'm using 3 gigs of RAM. My CPU is falling asleep. Here's FFmpeg. I'm streaming from FFmpeg, and it's just like it's not doing anything. You know, it's using like 5%, and it's capturing and encoding, and I'm streaming to Twitch and YouTube at the same time and keeping a local copy. So yeah, and this is just a laptop, so it's C, man. See, it can do it. You know. No, the interface is fine. It's moving at this speed because I told it to move at this speed. And again, I'm recording at 30 frames a second, so you might see this slower looking than it actually is for me. You know, it's happening at 60 FPS for me, but that's the speed that I've set it to scroll out. It's like 10 or 20 pixels per frame, something like that. I forget. Anyway, I got to wrap it up because I got to eat and make dinner and eat nothing. So I'm going to cut this up and maybe into different videos, but I hope you guys enjoyed that. If you have any questions, just ask me at the, you know, whatever video that you had the question on, just ask it below. And thanks for watching, you guys. Have a good day. See you next time.